Okay. Sampling distributions. All this section is about, or this unit is trying to find probabilities for a sample proportion and a sample mean. And how we're going to find those probabilities is doing the normal approximation. Like we want to be able to use table A, z-scores, or just use normal CDF from the calculator. But in order to do that, we have to make sure that these distributions are approximately normal first. And then the next unit, the unit after that, we're still going to be using sampling distributions in these same conditions. So it's really helpful if you're able to distinguish between these things now. And then the rest of the units in this course are actually going to be probably pretty easy for you. Anyhow, let's get to this. So these problems, they're pretty long. They require a lot of steps. So how I would like you to answer these is following this format. It's called the 4-step process, where you state the problem, plan it out, where you're checking conditions, do some calculating, and then write a conclusion statement. So let's go through the state, plan, do, conclude process, format, whatever. And then we'll do some example problems. So state, that is where you would start this off. For now, all we're doing is writing a probability statement. That's the only thing we're doing. In the next chapter, we'll do like confidence intervals. And after that, we'll test claims. But anyhow, for now, always try to write the statement that you're actually trying to find. Here's an example. Like this would be, we want to find the probability that our sample has a mean greater than 198, but less than 213. And then one more thing is always try to add context. Like, what's this the mean of? So you could say something along the lines of, like, X bar is the mean of the samples, like you'll see on the next page, GPA. That doesn't make any sense because I have 198 and 213. What? Just add some context to it. Try to add at least a little bit of context to it. And then what you really need to, something that's very important in these questions, always pick out what the sample size is. N equals something. Always try to find what the sample size is. And then what I should also mention in this part is, in the state part, you are choosing the statistic here. Do you want to answer this problem using a sample mean, or would you rather answer this question using a sample proportion, p hat? So how do you know which one to pick? Should I pick a proportion or should I pick a mean? And a decent guide would just be use p hat, use proportions when dealing with, use p hat when dealing with successes and failures. When you're getting a proportion of successes to failures. That is when you would probably want to be using p hat. That's the statistic that you would want to use, successes, failures. Now, you would want to use X bar for typically like measurements. For measurements. So things like a car's miles per gallon. You're measuring its fuel efficiency. Probably want to describe that using a sample mean instead of a proportion. GPA, it's a measure of your academic success, I guess. It's a measure. I did not spell measurement correctly at all. What did I do there? Measurements, all better, maybe. Anyhow, pretty clear, huh? Hopefully. Okay. Fantastic. So state, not a lot to it. write a probability statement for now. Choose your variable, x bar p hat. All right, so after you're done doing that, once you choose your variable, write your probability statements, and add a little bit of context, move on to the plan step. So to find probabilities, as already mentioned, we want to use normal probabilities. We need to make sure we meet certain conditions. The conditions change just a little bit for which statistic you choose. So for sample proportions, the conditions are, I think we got a pretty good handle on these, maybe. The conditions for proportions are, the first thing, you must randomly sample. You have to check and make sure that the sample was randomly selected. The second condition for sample proportions is that large counts condition. And there's a little formula that goes along with this. The large counts condition is, since we're dealing with successes and failures, the number of successes, or n times p, needs to be greater than or equal to 10. And the number of failures, n times 1 minus p, must be greater than or equal to 10. Literally all that means. The number of successes and failures should be at least 10. That's in order to get the shape like approximately normal. And then, hey, the third condition for sample proportions is that 10% rule. Sample size needs to be less than or equal to 10% of the population. Because if I sample too much, I won't have any variation. I won't actually be able to find a standard deviation. Okay, the 10% rule is probably the most challenging thing to really understand. Do you want me to like explain why we need that to be true?
Yes, please.
Son of a, let's do this thing. All right, so that has to be true because of like what we're trying to do. Okay. It's like 3 or 4 or 5. It's quite a few today. Let me add some stuff here. So this is just side note on the 10% rule. So let's go with a hypothetical situation here where we have a normal population with a mean. The mean of our population is 20. That's all we really need. Oh, and then a population size is 1,000. So we've got 1,000 people in our population. The mean of this population is 20. And I guess it'll help if I give you like a little bit of context, visualize what's happening here. The ACT score, so like the average ACT score from this population is 20. It's 1,000 students. If I got all 1,000 students and found the average, their average ACT score is a 20. So if I was to sketch this out, like this, we know it's normal, and we know that the center is at 20. Good deal. So let's say I randomly select some people from this population. I randomly select some students from this group, and I find the average. I find an X bar. So one thing that we know, when you go sample size, what if I chose all 1,000 students and I found the mean. What if I sampled every student and then found the mean? Just like off the top of your head, maybe? Like, do you know what this is going to be equal to? Not so clear what I'm trying to ask. We know that all 1,000 students have an average ACT score of 20. So if I chose to have all 1,000 students in my sample, and I calculated the average of that sample, I would get 20. Exactly. I would get 20. If I did this again, if I got all 1,000 students again, calculated the average, I would get, once more, my sample mean would be 20. If I did it again, I'm going to get 20. So for the sample, this is what the distribution would like end up looking like. Instead of being nice and spread out, some students do really well in the ACT, some students do very poorly. If I used this to create my sampling distribution, my distribution would look like this. So our x-axis would be the ACT score. I would get an average of 20 every single time. I would never get an average of 21 or an average of 19. So if I sample way too much, I don't have any variation whatsoever. Very clear, right? That is not normal. Normal distributions have variation. They have people that score very well. They have people that score not so great. They have a lot of people close to the mean, but not exactly at the mean. And that's really the gist of it. I can't sample too much because if I did, the standard deviation would be 0. I have no variation in this distribution, and that's not good. We want some variation because we're wanting to find probabilities. So the 10% rule, it really just makes sure the 10% rule is there. Why is it there? The 10% rule is there to ensure that we have enough variation. It's there to ensure that we have enough variation. We want our data to be spread out at least a little bit. It's going to decrease the larger the sample size, and that's fine, but if I sample too much, I just wouldn't have enough variation to really do any calculations. Okay, so regarding the same example, like here's the rule to check, right? Your sample size needs to be less than or equal to 10% of the population. So if my sample size was 1,000, my population size was 1,000, I go about trying to check this condition. You see that this statement is not true. 1,000 is not less than or equal to 100. So that means it doesn't pass the 10% rule. We don't have enough variation at that point. Good deal? So like there are plenty of samples that would work. Like I could absolutely, from this school or from this set of students, I could absolutely randomly select like 80 students. Because, of course, 80 would be less than or equal to 100. Cool. Hey, what do you think? Much more clear why we do this? Fantastic. Okay, I'm gonna go back to our notes then. Any other questions regarding this thing? Oh. All right. 10% rule. So just check it. Probably the hardest one to really get a good grip on, understand why. But that's it. And those are the three conditions for sample proportion. That's it. All those go together with p hats. Now sample means, on the other hand, quite a bit different, even though it's like honestly mostly the same condition. So for sample means, the first condition that you want to check, always make sure that the sample came from a randomized method. The first condition is still random. The third condition is still the 10% rule. Now the second condition on this one, it's another thing that's probably going to end up confusing maybe at least a few of you. The second condition is, there's actually two. It's kind of like a 2A and 2B for this, I guess. There's two ways to meet this condition for means for X bars. One of them is the population is normal to begin with. If the population is normal, bam, you check that box, move on to the next piece. The population is normal, good to go. If the population is not normal, if you start off with like a skewed or bimodal distribution, you can also check this. It's or the central limit theorem is met. The central limit theorem is met. That would have been like a good pop quiz question, maybe. Do you remember what that like actually refers to? Central limit theorem. It is, if I repeatedly find an average from a group, from a population, the distribution is going to be normal so long as the sample size is greater than or equal to 30. Remember me doing that with you the other day? It was on Tuesday, I think. I was projecting those graphs. It didn't matter how weird I made the population distribution. As long as I sampled enough, the distribution that we created was normal. And that's it. Those are the conditions for sample means, okay? Fantastic. Those all go together. All right. State the problem, check these conditions. And then finally, we get to actually do some calculating. Let's move on to the do step. State, plan, do, conclude. So for the do step, this is where we're actually going to find our probability. In order to find the probability, we need to find the measures of center, the mean, and we need to find the standard deviation. Let's just jot down the formulas one more time. A nice, easy place to find. So the mean of a proportion, very easy. It's just equal to the population's proportion. The mean of our sample should be equal to the mean of the population. Okay, now the standard deviation for proportions is equal to, this one requires a little bit of work. And it's a lot like the binomial distribution standard deviation. So this one is the proportion times 1 minus the proportion, all divided by the sample size. That's the only difference. We're dividing so we can actually get like decimal values instead of counts. Okay. Remember, these all kind of go together. If you choose a sample proportion, you need to check these conditions and use these two formulas. Those all go together with proportion. Means if you choose a sample mean as your statistic, go through these conditions and use these formulas, which are mean is mean of our sample, of our sampling distribution, should be equal to the population mean. So going back to this little thing that I was doing, if I randomly selected 80 students from this population, found the mean, and then I randomly selected another 80 students, found the mean, and then just kept doing that, their average would be 20. Good deal? All right, so that's it. Standard deviation of this, the population divided by the square root of the sample size. Have all this information in one nice, single, easy to find page, right? Fantastic. In that do part, you're gonna have to do this. You're gonna have to find the mean and standard deviation. When you do have those things, you can finally just take the shortcut method and use normal CDF to find your probability. Just never forget to do this thing here. Never ever forget this step. A good way to make sure that you get full credit, check your work right away. Always draw and shade in a normal curve. Always, always do that. Sketch a normal curve, plot the center, and then just make like 2 marks for where the area is that you're trying to find, and then shade that in. Always do that, okay? For your calculation part. Find your probability after you draw your normal curve. It will help your percentage make like way more sense. All right, we're almost done with these. Like, very last thing, include. Write a statement that includes the result you found from the do step. And as always, with statistics, just make sure you add some context to it. So like here's an example using 198 through 13. Probability of sample mean of student weights. You know, there's just a little bit of context regarding that variable from a sample size of whatever falls within this range. It's approximately some percentage. Don't skip the conclude step. Might seem like really, I don't know, like mundane or something at this point, because we really are just finding a probability. But eventually, this is for the next unit and the unit after that, to wrap up the entire AP Statistics course. Eventually, this is where we test claims. We will actually prove that a claim is false or not false. So you want to get good at this now. Be able to interpret this statement. It's really going to help you out for the next section that we covered. And I've been trying to sprinkle this in throughout the entire course. Like, you have a decent idea, hopefully, of how to test claims. There's like this rule you can follow. Like, what we're eventually going to say here is, do we have convincing evidence? That whole like 5% thing, you know? Anyhow, I got some examples on the back that we can work through to practice using this 4-step process. So yeah, 2 questions. 2 questions only. It should go quick, since we have a better idea of how to do these problems. So what do you want to do? Do you want me to like copy with these right now, or want to just try them on your own? What do you think? Walk you through the setup and how to do it, or do you feel pretty confident you could just get these done by yourselves?
I personally would like
do it. Absolutely. Let's go through these example problems real quick.